Hello, everybody. We will start the webinar now. I would like to welcome all of you today for the second webinar in the first edition of the GAWTEC webinars. The first webinar has happened last week and is now available online. In case you've missed it, you can still watch it. We will post the link in the chat. And it's my great pleasure that we are today here with Andrea Kaiser-Weiss. And we will shortly start. I would like to welcome you on behalf of the World Meteorological Organization's Global Atmosphere Watch program, the GAW Education and Training Center, and the YES community. I would like to briefly introduce for this webinar our code of conduct. So just please be polite and respectful to the speaker and all participants. Please keep muted and your video closed, but you can type questions the moment you have them in the chat box and we will address them after the webinar. The webinar is recorded and also the content of the messages, and an outcome report will be published after the webinar series. And now with that, I would like to hand over to Sonja Böll from GAWTEC.
Yes, I'd like to introduce our speaker today. We're very happy to have Dr. Andrea Kaiser-Weiss with us. She's leading the group Greenhouse Gas Emission Verification at the DVD, the German Weather Service in Germany, and is also involved in related research projects. Her 20-year background in atmospheric sciences include work on regional reanalysis and climate data at the DVD. At University of Reading, she was a project officer of the Group for High Resolution Sea Surface Temperature and had worked on satellite data assimilation, and also the science case for the truth emission. Early work included leading the group on air pollution modeling at the EMPER in Switzerland, and in her PhD at the ETH in Zurich, she separated anthropogenic and dynamic contributions to stratospheric ozone trends. Today, she will talk about modeling air masses and the impacts of the corona lockdown. Thank you, Andrea, for being here today, and the floor is yours.
Hello, everybody. Can you hear me? Good. First of all, thanks to the organizers for inviting me and allowing me the opportunity to show some results and also some ideas of my work. I hope that you can take away something interesting from this talk, and who knows, maybe someday we work together. All right. So I will show you, got the mouse right, what's my plan for today. First of all, I'll give a small introduction and motivate the air mass modeling we do. I'd like especially to point out the difference between the global and local scale. I will briefly touch the COVID effects for Germany, but in the fourth part, I plan to be more general because I know that many of you are in different parts of the world. And I'd like to point you to some important reports who just came out last week and relate the impact of the corona lockdown to the emission gaps we are facing for the climate problem. And then I give a short summary. All right, I don't know what your background is. I try to have a mix of easily digestive slides and more information loaded slides. I hope there's something for everybody. Right, for introduction, I'm from the German National Weather Service, that's Deutscher Wetterdienst. We, of course, observe and forecast the weather, issue weather warnings, study the climate in Germany, evaluate the changes of climate, provide climate change consultancy, monitor radioactivity in the atmosphere, and represent Germany in international organizations. And it didn't slip our attention that it's getting warmer. You see a plot here about the summer in Germany. It's the anomalies. On the left-hand side, there is the scale. in Kelvin, and the time scale goes from 1890, so we have first measurements from the 1870s to now. And you'll realize that negative anomalies get less and less, and in the last years we only have positive anomalies relative to 1961 to 90. And of course this is in line with a general picture that the whole world is getting hotter. And the World Meteorological Organization issued this quite remarkable sentence that we now have the 6 warmest years on record, which were all in the 6 past years. So would be interesting to see how this is in your country. In general, it's clear the climate problem is quite a hard nut. Huh? It might be a beautiful problem, but it still is very hard to crack. It's definitely an obstacle for politicians because greenhouse gases are simply invisible. It would be completely different if you could see them in the air. But no, our problem is invisible. We have many sources and players. We have some unknowns. The consequences are expected not just now, but decades ahead, and it threatens our civilization. Right, what can we do about it? We need tools. We need to prepare an operational support for policy and decision makers. And here I show you an example from Ed Hawkins, University of Reading. And I'd like to know, and it will be in a poll soon, whether you know you can generate these stripes for your country with a website which is shown here, or whether you might have already done that. So I think this is an example of a good tool what policy and decision makers can immediately understand and use to make sensible climate policies. Right, so I don't know whether it works, but we can have a question here for the poll. Here it is. So please be so nice and see whether you know that whether the media of your country have already used these climate stripes. It would be interesting to hear. So whether you have seen an image of these blue to red stripes in a newspaper or in, I don't know, some other media. Okay, maybe we give you a few more seconds to think about it. And I continue. Okay. So the poll is still open. That doesn't matter. Maybe I can move it, or you can move it. No, I can't move it. I have to wait until the question is closed, and then I can continue. The next slide. Thank you. Here I show the CO2 concentrations at the mountain stations, Zugspitze and Mauna Loa. When you have been following the GAWTEC seminars, you know where Zugspitze is. It's a mountain in Germany. Mauna Loa is at Hawaii. And of course, it's the rising greenhouse gas concentrations which are responsible for our rising temperatures. The concentrations measured at Zugspitze and Mauna Loa follow each other closely and clearly show the rise in CO2. I give you another useful web page, CO2 Earth, where you can look at the daily value of the global CO2. And here you see that we had on Sunday 413.66 ppm. And if you compare that to last year, you see that we have about 2 ppm difference. I'd like you to keep that in mind, 2 ppm rise over the year. Right. That's the source of information. Okay. The difficulty of the climate problem is that we have a global problem and which requires action on a local scale. So local scales, say states, cities, individuals. And that means we need research operations and actions at the global, national and subnational scales. And we also have to interact between the scales. One can look at it in a different way as well. So on one hand, we have the global greenhouse gas concentrations, which are relevant for the temperature or the climate. And on the other hand, we have the local emissions, which are relevant for the international treaties. So it's not so easy to go from one side to the other, but there are many projects involved in this. For instance, IGIS, which I will go into as an umbrella for this a few slides later. At the moment, I wanted to point out, to go from the concentrations to the emissions, we need, of course, for observations, but we also need modeling. And if we want really to derive the emissions from the concentrations, we need an inverse modeling, right? So if we go from the emissions to the concentrations, I forgot the poll. We require a forward model. And I forgot about that we planned a poll. And we would like to know, just from your information or gut feeling or from your experience, whether you think the decision makers need more infographics from scientists. Yes, no, or maybe. Yeah, what's the situation in, I don't know, your country or your peer group? We would like to know what your to this question. Okay, give you a few seconds to think about it. And I can continue that as both the concentrations and both the emissions are invisible, we are looking for something we can show the politicians, show the problem, show the solutions, show that there was progress or none. And to do so, we require a forward model if you want to go from the emissions to the concentrations. And we require an inverse model when we want to go from the concentrations to the emissions. Right? Now, this is a more complex graphic. I promised you to tell about the umbrella for greenhouse gas emission verification, because if you would be in Germany, we probably have met already if you are working on this. But if you are in a different country, then it is good to know that there's a group organized from the World Meteorological Organization named Integrated Global Greenhouse Gas Information System, where all the efforts are collected. So if you are working on the observation side, that's all in blue in the top row, or if you are more working on the inventory side or a stakeholder, which is marked in green here, this is all part of what is discussed within the IGIS. The main bit is what's here in orange. So what I said before, either the forward or the inverse model, how you relate between the word of the concentration observations or the emission estimates. And there are many different techniques which are needed for that. So that's why I said in the beginning, maybe you are working on a particular aspect so that we can meet again when we put all the efforts together. Okay, if you're interested in this, go to the website, there's plenty of information. I would like to recap here how our science relates to politics, starting from the United Nations Framework Convention on Climate Change. We had with the Paris Agreement that a global stocktake is done every 5 years. Then the national determined contributions and the national inventories and reports feed into that. And we also have the IPCC, which does the guidelines needed for this. And Global Atmosphere Watch and WMO had a memorandum of understanding about collaborative projects. Of course, first of all, annual reporting on atmospheric greenhouse gas concentrations and the state of the global climate. The point which is closer to this talk is the observation-based tools for an improved national greenhouse gas emission estimate. That's the IGES objective. And then there are also climate services and regional collaboration set up. But this is how the science really fits into the politics. And in the guidelines now is you can look them up, the 2019 refinements of the IPCC 2006 inventory guidelines. You can look up there what is the state of the art for verification of emission estimates. And it contains the observation-based emission estimation. Right, let me check whether we have a question after this slide. Yes. I think we have a question to the audience here. This is interesting. This is the answer of the answer whether climate stripes have been used. It's about half. Some potential there. That means you can generate the stripes for your country with the link you had on the slide and can give it to your media, right? Yes, the decision makers need infographic from scientists. I very much believe so. And this is a part of the motivation of my work. Yeah. And there might be some politicians which don't need these. That's also correct. Yeah. And now the question, yeah. We have the answers here, not the question, not another question. Another question will come after slide 16, I think. Right. So let's leave the politics aside for a moment and continue with the global versus the local scale and what we can learn from the COVID situation. All right. I don't know how many of you have seen that. This is a slide I took from the SBSTA meeting this summer. The WMO GAWTEC Global Network for CO2 measures the global CO2 concentrations. Here it is shown on the left-hand side Cape Grim, on the right-hand side Mauna Loa observations. The top panels is the rise over years since 1980. In the lower panels it is blown up the time scale from 2015 or 16. And just to give you the general picture, of course, is rising. Very interesting is the panel in the middle. You remember we said we had 2 ppm more this year than last year. Well, it's not every year the same, these 2 ppm. Some years is as little as 1 ppm. This is the red line I'd like you to look at here. Some years as little as 1 ppm, and some years is as high as 3 ppm difference to the previous year. So we have about 1 ppm natural interannual variability. And it's already written on the slide that the lockdown measures compared with due to COVID decrease the growth rate by approximately 0.2 ppm max. So 0.2 ppm is small compared to the annual variability and is also too small to measure for the global stations. All right, so for the global effect, safe to say that the COVID-19 effect is buried in the variability of the measured CO2 concentrations. However, if you look at the local scale, and this is work of ICOS, where at towers the CO2 flux is measured, you can clearly see the effect of COVID-19. So these are 8 panels of 8 different locations. In red is the CO2 flux of this year, 2020. In gray, for comparison, is the CO2 flux of the year before. And you see here the time period between approx 10th February and 30th of April. And every time that red is smaller than gray, you see this is the reduction. It's compared with, you might see a yellow bar here, that is light yellow is a light lockdown and dark yellow is a heavy lockdown. You see how these reductions in 2020 are clearly when the lockdowns are in place. So in Europe, at least, we have clear evidence of reduction in the urban CO2 emissions. And now a question is, in your poll, well, you guess, how much will that affect the temperature if you look at the global effect? Is either you know it already or you can have a guess from the general magnitude of the effect. So do you think it's rather an order of a degree or an order of 0.1 degree or of an order of 0.01 degree? Take your choice. I'm curious what you think. The solution will come much later in the talk. Okay, if you're interested in this particular measurements, there's again the source of this study shown on the slide. For you later. Okay. I'm here just showing what we measured in Germany. So there are 8 ICOS towers, tall towers to measure in Germany. Here it's the concentration shown for each of the different stations in different color, all plotted on top of each other. And you see there are significant spikes in there. That's why a running mean is added. This black running mean shows you that first of all, you see an annual cycle in there, which is because of the vegetation effect. And if you look carefully, you can also see within these 5 years, the rise in the background. So generally, the CO2 is higher than the years before. If you look closely at the area at the beginning of April, which I marked with the green bar there, it doesn't look as if there's a significant change in the concentrations. It was a bit surprising that we do not have any negative spikes, so we don't have any fresh air coming in. This is absolutely within what you would expect if you look at the weather. We had very beautiful weather at this time in Germany, but stagnant air. So we missed the fresh inflow from the sea. Okay, so we asked ourselves, how large would the effect be we expect at the stations? This is why we model the air masses to estimate the size of a coronal lockdown effect on the CO2 concentrations. And we thought we forget about the background, we just do freshly emitted anthropogenic CO2 within Germany only and see how large the effect should be. We put an Edgar inventory below, but it's not the main issue. The issue is that all around Germany it is set to 0 and look only where the emissions from Germany are going. And I invite you here to go with me through the slides. This is after 12 hours and after a day, and 2 days and so on. And you see within a few days, the German emissions are distributed all around Europe. The interesting bit is in the color scale. So when it becomes yellow, the concentration is about 1 ppm. So that's something you could measure. If you are in the red area or even in the small pinkish areas, you go from 10 to 100 ppm, so that's a strong signal. And if you would expect a reduction, I don't know, by 20% or so, 20% from 100, of course 20 ppm, that should be easily to be measured. Right. Now we compare the emissions we have from Germany from the emissions we expect outside Germany. So the same thing, just we said in Germany we won't have any emission at all, and we have emissions in all of the world. Again, no vegetations, no background, just the fresh emissions. And again, I go through the different days, and you can see that the air is mixed. And if you have several days, it even can cross continents. I don't know in which area of the world you are listening, but you probably are watching your own area most closely here. Again, something what is red would have a potential to measure a COVID effect. Something what's only yellow, probably not. And oops, yeah, so I stay with that for a moment. And it's clear that you have CO2 emissions mixed and transported around the world in a few days. It's also clear it will take a few months until this is all mixed. That in the southern hemisphere that you get all our polluted air, that will take a time. So it will take a time something shows up in Mauna Loa, Cape Grim. Right. We were interested in Germany here, compared the homemade and imported concentrations we are going to get. This is a near ground plot. So in the model, I have the luxury that I can choose which height I'm interested in. So that's near ground. And in this case, I was pleased to see that we rather would measure the homemade CO2 than the important one. So this is 1 to 2 magnitudes larger, the homemade, than the imported. And if you look where our towers are situated, and also look at now not at the ground, but at 100-meter height, we clearly see that at 100-meter height, the picture is different. There the imported can be 2 magnitudes higher than the homemade, depending on where the wind is coming from, of course. And the other towers, they had, depending where they are and what the situation is, a similar point, that the homemade and imported was more the same size. Now somebody could say, oh, you have the towers in the wrong location, but that's not so, because the towers are particularly set up to measure background. And it also tells us if we want to measure emissions, we need more measurements close to the sources. Right. I like to do a recap here. Locally, emission reductions can have a measurable magnitude in the greenhouse gas concentrations. At the same time, the effect remains elusive at the global scale because of the high background concentrations, or another way to put it is because of the long lifetime of greenhouse gases. And the atmospheric modeling can show us at which time or at which weather condition which air masses are sampled. The height matters significantly. So whether you measure at 100 meter or at the ground or even at a mountaintop, that gives you completely different air masses. And that goes back to the talk Martin Steinbacher was doing last week. And he pointed out one has to think carefully what you want to measure when you set up your measurement station. All right. So the background contribution, regional contributions, local contributions very much will depend on where exactly you are measuring. Okay. Well, this was the easy bit. We went from the greenhouse gas emissions to the concentrations, and we simply used as a forward model our ICANN weather model with online passive tracer transport, which is calculated with the ART module. The good thing is that it has an exact local mass conservation and mass consistent transport. So if you use a weather model to transport any passive tracers or any tracers, this is an important point, whether it conserves mass. Right, if you're interested in that, there's a link. And I'll come to my next point, but I think we have another question for you here first. The question is, a climate-friendly corona crisis recovery. will have the potential to reduce emissions less than the Paris Agreement or several times more than the Paris Agreement. So if you think about what Corona did to the CO2 and what a recovery could do to our emissions and what Paris has to do for our climate, you could judge what you guess, or maybe you know it. Yeah, this will be answered later as well. It's about the magnitude of a problem we are facing. So take your choice. Okay. I think we had another question at this point as well. All right. So the question is whether reduced emissions can be easily confirmed by measurements and models on the local scale, the regional scale, and on the global scale. Well, easily is maybe a bit not well defined. Just about your impression, or what would be easy for you with your background, your tools you have in hand. That's what is meant. Do you think you could easily confirm on a local scale, regional scale, or global scale with measurement and modeling? Yeah, maybe it's a hard question. The point is mainly to think about it. All right. So go back to the outline. We covered the motivation. We already covered the regional COVID-19 effect. But I would go a bit further. I would like to extend to air mass modeling for emission verification in the next part. So I believe that if we are good at modeling air masses for emission verification, this gives a powerful tool to decision makers. And that's why it's really worth pursuing. What we plan is in Germany that on one hand side, we have, of course, national inventories, which are very well established, but we would like to give us to put to the side, give us an additional information, all what we can get from the concentration and flux measurements, be it towers or masts, from ICOS or other ground measurements, aircraft measurements, satellite measurements, use those to deduce emission estimates as well. And by comparing these both ways, we will learn a lot. Yes, and it will advance our knowledge in this respect. All right. Just a quick recap. We are in a good position in Germany that we have 8 towers. I know that maybe not in every country you are in the same position. Yeah, but well, it all goes around the world. And even if you don't have a tower in your own country, then you could do air mass modeling. So we have the towers. We also have ICOS ecosystem and ocean stations. Terrain observations, also mast observations in different areas, just to show you that there really are different observations around. Also TCON, COCON, which is remote sensing, IAGOS, which are measurement on the airlines, and the satellite measurements. There are plenty measurements which can be used. We have already some knowledge about the emissions. Just to give you an idea about what's going on in Germany, it's of course mainly from the energy that we have CO2 emissions. Transport is significant, industry not so much. And we have the methane, of course, from animal husbandry, cropland, grass management. And our natural CO2 uptake is not that large, but is scientifically interesting. To get these numbers right, to get the uncertainties right. Okay, what do we also know? We also have from Copernicus an estimate for the global background. This is very important that we can use this. So we can, in an area which covers Europe, calculate ourselves with a high resolution and with the best possible emission estimates, the concentrations we are expecting, and compare these to the actual observations and then do the inverse modeling. So, of course, we need a forward model, a good one, and the difficult bit is the inverse model. And we are working together in Germany at a national initiative and hope to make progress over the next years. So if you plan something similar, what do you need? You need boundary conditions, very important. You need observations. Of course, you need a few assumptions on the inventories, and you need the inverse models. So the same thing could be done in a different country, and then it would be nice to meet it, I guess, if you do something similar. Right. Now I want to go more to the general point, how the corona lockdown compares to the emission gap. And here I draw on the material of two publications, the emission gap report and the global carbon budget, which came out last week. So if you're interested in anything to do with carbon budget, the best page to go to is written there, the source. Very good information, very good infographics. And I want to point out to you here that in this graphic, which goes from 1999 to 2020, it's shown how many gigaton CO2 per year are emitted. So this had been rising all the time. Okay, the rise was a bit slower than the decade before, which was good. And 2020 brought this down by 2.4 billion tons. So that's a massive decrease. That's very good. 7% less. But you have to compare this with the 1 to 2 billion tons which are needed each year between 2020 and 2030 to limit climate change in line with the Paris Agreement goals. So although it went down pretty good this year, we know it has to continue to do so over the next 10 years. This is quite a big aim, right? We know in which areas or countries the developments are. This is very nice. Global Carbon Atlas. You can also find your own country there and how the emissions changed. I start here with India. So in India had not so emissions in the past, but it's growing fast. However, for COVID, it went down 9.1%. Then European Union, the growth stopped about 80s, and since then it's slowly declining, and since 2010 it's declining a bit stronger, which is good. And this year brought it another 11% down. USA is declining CO2 emissions since the 2000 years and had a 12% drop. China was rising fast, leveling off in the last decade, and only a small impact by COVID, and all others you see in this line on top, about 7% down. If you look at the other hiccups in this graph, this was, for instance, in the 90s, the decay of economies in the socialist countries, then quite often in the following years, the CO2 emissions pick up again. If you, for instance, look at the financial crisis, 2008, it was just down 1 year, and the next year it shot up again. Right. If we look at the different sectors, this is quite interesting as well. It's from this year, 2020 only, from January to October. You see that, of course, the power sector contributed to the decline in emissions. Mainly it was transport, ground transport, which declined. significantly, it's the largest contribution. And then we had industry, aviation, and shipping as well. But in October, we are pretty much back to normal here. So if we compare this with the emission gap, then the best reference is the UNEP emission gap report, which came out on 9th December 2020. Well, the gap, what is the gap? It is the difference between what is needed. Yes, this is here in green, the needed emission reductions, and what emission reductions are pledged, that is kind of promised in the international treaties. And the gap is significant. So the next slide, this is explained a bit more. Oh yes, I forgot my poll again. You put it in. So before we go into the details of the emission gap, have a look at the results. Your estimate what the difference will be. Yeah, the solution will come a bit later. Yeah, here you show the poll results for climate-friendly Corona crisis recovery. Less than Paris Agreement. Most of you thought. Several times more than Paris Agreement. Some of you estimated. We'll see. We come to the answers in the next slide. Yes, difficult to estimate. Okay, here I would like to draw your attention to, first of all, the blue line, which goes to current policy scenario. Our current policy scenario is, if you see the time, 2015 to 2030, that emissions are going up. Well, the good point is they're going up less than the 2010 policies would have done. So the current policy is already some achievement compared to 2010. However, they're still going up. So if the Paris Agreement are fulfilled, then the emissions will go up not quite so much. That's the orange line. If even the conditional, so the most ambitious efforts of Paris are fulfilled, which is the red line, then the emissions would, we are now at 2020, stay level, which would be quite an enormous endeavor. However, to go down to our 1.5 degree or 2 degree warming, we would need the emission going down significantly more. So in addition to the Paris Agreement, so if we go to either the orange or the red line, we need further 12 or 32 gigaton CO2 emissions going down in the next 10 years to limit to 2 or 1.5 degree warming. So that's significantly more is needed than is pledged at Paris. All right. And now I would like to point you to a video from UNEP, which brings a solution or suggests a solution here. On one hand, despite we have a dip in CO2 emissions by the COVID-19 pandemic, the world is still heading for temperature rise in excess of 3 degrees this century. But a low carbon recovery could cut 25% of the emissions we expect to see in 2030. That is a significant bit. And if you are interested in this, I very much recommend you to follow this video, which is done only a few minutes and all the most important things mentioned. You can find with this short link over there. Antonio Guterres, our General Secretary, told about the conclusions from the emission gap report. So we expect a 7% fall in emissions, and this means only 0.01 degree reduction of global warming by 2050. The full implementation of Paris would reduce the emissions by 4 to 5%, 2030. And the ambitious NDCs would be 9%, and this is much less than a low carbon recovery could give you. So now the countries either have to threefold increase their ambitions or fivefold their ambitions for 1.5 degree, or they invest in a low carbon recovery, and that gives them approximately what's needed. So a low carbon recovery from the COVID situation is a magic bullet which shouldn't be wasted. That's my point I wanted to make here. All right, we had seen your answers already for the previous two questions. Let me read whether the reduced emissions can be easily confirmed by measurement and models. So it's distributed between locally, regionally, and globally in similar numbers. You estimate that it's easiest to do the regional. I agree with that, but it depends always on the models and the measurements you have in hand. I think that's a sensible judgment you gave there. And I think I will recap now. Yes, one thing when you're listening, I wanted to point out, please note the units, whether something is carbon or CO2 equivalent. That includes also the methane and N2O and all the other greenhouse gases. One can get mixed up if you compare the gigatons. So please note the units. Next point is note the scale, whether you're on a global scale or on a local scale. In principle, the climate problem is massive when you compare to COVID, but it's not so different. If we implement what we can learn from COVID, and if we don't waste this crisis, then there is a reasonable chance that the climate problem can be contained. So there is a huge potential for a climate-friendly COVID recovery. Atmospheric modeling can provide interpretation. I hope I convinced you. We need tools to achieve progress with the climate problem. We need the measurements, we need the modeling, and inversion methods all have a role here. And yes, cooperation is definitely desirable. So on my last slide, I'd like to thank my DWD colleagues who helped with the work and also with the presentation. I also like to thank at the Karlsruhe Institute of Technology, the group of Roland Runke and co-workers. And I also thank all my German colleagues who are planning together the integrated greenhouse gas monitoring system in Germany. Okay, thank you for listening. I hope you found it interesting, learned something, got a new idea. Would be glad to hear from you. Thank you.
Thank you very much, Andrea. It was very interesting, and we have a lot of questions which we like to answer now. I would read out the first one. Have you prepared a plot that shows not only the CO2 concentration changes, but combines the CO2 and other greenhouse gas changes in CO2 effective units? So maybe you do not.
Yes, I don't have a plot at hand, but one could easily add all these different model results on top of each other. So you can add the CO2 emissions of Germany and add the CO2 emissions of the world, if that was the question. And this would give you the CO2 signal from this period. And then you should add the background as well, not to forget to add the background. So you can get that from Copernicus comes. And this gives you a time series you can then compare to measurements. Was that a question?
Thank you very much, Andrea, for responding to the question and also for the impressive talk. I really enjoyed it. We take the second question, and the second question says, Are all signatories to the Paris Agreement providing greenhouse gas emissions measurement or estimation?
I understood the question, whether all the signatories promised measurements and modeling was the question, yeah?
Measurement estimation or estimate.
Estimation.
Yeah.
Well, if you are signing the Paris Agreement, you have to hand in an emission estimate. That does not necessarily mean that you do a measurement, but you have to do an emission estimate. And how this should be done is done outlined in the IPCC guidelines. And then it depends, there are different batches of countries who pledged for, let's say, different sophistication, because sometimes you have a small country where the effort would be really a bit too much. And so it depends on which batch your country belongs to. I'm missing the right words for that. So if somebody else has it, it's possible to look it up. What your country, first of all, what emissions were promised and with what methods they are estimated. Yeah, tier is the right word. There are different tiers. And you have to look up with your country to which tier it belongs.
Thank you, Andrea. The next question is, what is the uncertainty of the flux measurements in cities?
It's a good question. No, I don't know that. Yes, I would ask the people who are doing the measurement. And well, if you send this over to me as an email, I find the right people. Because first of all, it's quite important where you measure. So it's the question, how representative is your measurement, of course. And then you would ask, how would you make sure that you pick an area where you're reasonably representative? Yes, and it's not easy to answer. Well, if you measure at a point, then you are normally, you know exactly what's happening on this point, but you can't know how representative it is. So it's a little bit a difference whether you measure in a park or whether you measure beside a street. And that's not the only thing that matters. The other thing that matters is at which height you're measuring. The flux measurements normally in the cities, they're not in very large heights. So it is hopefully a place which is chosen to be reasonably representative. It could be checked if you have mobile measurements which you move around, and then you can really check whether you get significantly different results when you move your measurement station to a different location. Okay.
Thank you, Andrea. The next question is from Manish Soni, and he's asking, is the EDGAR an emission inventory for anthropogenic emissions available now for use? And the second question is, what are the other pollutants that are covered?
Well, you could go to the EDGAR emission inventory. That's a good one. And it's not only CO2, you can find different pollutants there. But EDGAR is, I think, free to use. And it's a global emission inventory. There are other inventories around as well, but that would be a good starting point. The link is on one of the slides, hopefully. Well, I mentioned EDGAR, so maybe you have to Google EDGAR. I'm not sure if I provided the link. Yeah, Google EDGAR, and if you don't find it, you send an email.
So next question, it's more true or false sentence. Tracking a moving average of CO2 minima appear to be a better measurement of CO2 changes over time. Vegetation and uptake mechanism are likely to be less variable than emissions. Is this true or rather not?
Well, it's a valid point, that you have, first of all, you have to take into account vegetation if you want to quantify the emissions. Well, the point I was looking at, I wasn't interested in the vegetation. That's why we only wanted to know what is the magnitude of the effect we are expecting. So that's why in this respect, we didn't need the vegetation. On the other hand, if the vegetation effect would mask the COVID effect, then you would need to look at it. I just try to figure out what the question is. The point is that you can, if you only track the minimum, yeah, but the minimum will be very much influenced by vegetation uptake. So surely you can look at different effects, whether you look at the minimum or the maximum or the median. Which one is best will depend on what question you want to answer. Yeah.
Thank you very much, Andrea. We can take the next question. And this one is saying, can we use the icon art over India?
In principle, yes, it's a global model. There are other, it's not only used in Germany, there are different countries which use icon or icon art. You would have to be part of the icon consortium to do so. And well, the main point is that if you do developments on the code, then everybody should be able to use it as well. So I think, but if you're interested in principle about using an icon, then yeah, also you send an email and I can forward to the appropriate people.
Thank you. And the next question is, does inverse modeling of CO2 emissions compare favorably with emission estimates provided by European countries?
Compare favorably. I'd say emission estimates provided by European countries are often done with a very high effort, and they're probably very good. And then the question arises, what additional information can you provide with inverse modeling? And although the emission estimates are excellent, it is a completely different way to look at the problem, and that's why there is additional information in. Of course, if one would have perfect knowledge of everything, then yeah, you could say we don't know much about it. But also the emission inventory is not totally perfect. There are uncertainties, either known or not known, which can be revealed. On the other hand, the emission inventories often are just a collection of data over all the year and all the country. So if you want to serve some politicians in some state of Germany, for instance, I'm in Hesse, they ask where are the biggest polluters and which time of the year. That's something the emission inventories can't. They can't answer. So it's the spatial resolution and the time resolution, and also the unexpected effects. For instance, with COVID, it will take a long time until you collected all the information to do a proper inventory. With the model, you can start very quickly and get an idea. What else did we have? We had quite a large fire in Germany, and this was also something the inventories couldn't estimate, because they depend on industry and also state agencies to provide them with data. So they collect everything what is known. Anything what's not known won't show up in inventory, and for this you need measurements and modeling. Okay.
Right. Thank you. Thank you, Andrea. And we are going to the last ones. A question from Ashish Kumar. He says, climate change exists earlier also, and it is the law of nature, but why we talk about climate change only not climate change in terms of acceleration or deceleration?
I'm not sure I got the question. What was the last sentence?
Well, why we talk about climate change only, not climate change in terms of acceleration or deceleration?
Acceleration and deacceleration?
Yeah.
Well, I haven't come across these terms. I'm not quite sure what is meant. So the beginning of the question was that there is also natural climate change?
Yeah, he says that climate change exists earlier also, and it is the law of nature, but why we talk about?
That's good to point this out again, because it depends again on scale. If you look at the last 500 million years, of course you have climate change for a variety of reasons. If you look at a time scale of a few decades, then the continental shifts are not responsible for the climate change. So it depends very much on the timescales you're looking at. What is the main factor? And in our times, and in this short timescales, so a few hundred years or maybe a few thousand years, which is a very small timescale compared to climate change in the last 4 billion years, it's absolutely clear that it's the emissions driving that. And acceleration, deacceleration, I just don't know what the content is here. One could also think whether the climate change accelerates due to passing certain tipping points. That's indeed a grave danger, that there are a few tipping points after which life will become difficult for humankind, and that's why it's so important to do something now, something about it, which is much easier now and much cheaper now. If we contain the emissions, if we reduce the emissions and have concentration of greenhouse gases, which are in accordance with the Paris Agreement. That's the sensible thing to do.
Yeah. Okay, the next question is how to determine whether a measurement is regionally representative in spatial and temporal scales.
Mm-hmm. Okay, yeah, that's first of all a good question. Well, I can judge whether my model is able to reproduce the measurement. And if that's the case, then I know that the main processes which are in my model are the main processes which are measured as well. And if I see, oh, I have so many differences here, then I'm still in the position that I can say, okay, they have some small scale differences, let's filter them out. And let's see whether all the small scale processes are averaged out if I take a temporal or a spatial average. So we can, by increase the time scale and the spatial scale, we filter out the smaller scale processes.
Thank you very much, Sonia. And then we have a few questions coming from Bumidi. First, he's asking, is there any tool for obtaining running averages? The second question is how to determine global warming potential of CO2. What is the difference between global warming potential and radiative forcing? Thank you.
Mm-hmm. So first, can you repeat the first question?
Yeah. Is there any tool for obtaining running averages?
Running averages? Well, any tool. Well, you just take 10 values and calculate the average, and then you move it a bit further, and you can be more sophisticated and add a weighting on top of this. I'm pretty sure that in most programming toolboxes you can define your moving average, and also with weighting functions. I guess if you don't, well, if you program it yourself, you know exactly what you're doing, but you probably can use some in R or Python, or I'm sure. So, but that's not so difficult, huh? You just count, I don't know, the number you want to have for moving average, calculate the sum and divide by the number, and then you move it along your time scale. And yes, that's straightforward. The next thing was global warming potential. Yeah, sorry?
Yeah, exactly. That
Yes.
was the question.
Yeah, but it is unrelated to the moving average, I think. So global warming potential is calculated by radiative transport. So you need a radiative transport model to calculate the global warming potential. There was something about the difference.
Yeah, and then the question was, what is the difference between global warming potential and radiative forcing?
Well, you can calculate both. I mean, you have different definitions, and yeah. You just you just check what you need or for which purpose you need this. It's a different, well, the global warming potential is for the temperature, and the radiative forcing tells you something about the radiation effect. So it's a different way to look at the same problem, right? Okay.
Okay, so I think these were all the questions now. We'd like to close the webinar now. Thank you again, Andrea, for your presentation. And we also like to introduce our upcoming webinar. It's on the 19th of January with also colleagues from the German Weather Service from Hohenpeißenberg. And the topic is the Integrated Carbon Observation System, ICOS, Tall Tower Greenhouse Gas Monitoring in Germany. You can register on our website. We will post the link in the chat box. Thank you very much for participating, and we hope to see you all in our next webinar.